We're trying to solve a problem here.
Tomorrow's going to be very exciting.
We are so excited about the future.
I will build your roads.
We don't need roads.
Hello, and welcome to Solving for Tomorrow, Tales from the Tech Frontier, the show about tackling the biggest problems in the universe with technology. I'm your host, Brian Geisel, CEO of Geisel Software. Today I'm here with Amit Ganjoo from ANRA Technologies. Amit has over 20 years of aviation, telecom, wireless experience in both the federal and commercial space, building his own airplane, all kinds of interesting stuff we're going to get into. Hey, thanks for being here today.
It's great to be here, Brian. I look forward to the chat today.
So I'm super interested about where the future is going in so many different places, in aviation and drones, and a ton of stuff that I think we're going to get into today. But I love to dig in first on like how we got here. So specifically for you, how'd you get here? What was the thing what was that spark that threw you into what you've become today and what you ended up doing?
So it's a long story. When I was a kid, I always was fascinated by anything aviation. And growing up, I always wanted to go to space. I wanted to work in aviation, become an aerospace engineer. You know, every kid's dream, looking at the sky. So I was all about that. So I grew up in India. So I always knew I wanted to be an engineer. So when I went into the engineering school, I ended up not going to aerospace. I ended up doing structural civil engineering. And but that aerospace bug was always with me. And then fast forward many years, I went to grad school for computer science and civil engineering. But I didn't manage to get my pilot's license. So that kind of rekindled everything. And then it's a funny story. I was at an event in a meeting one day, and someone told me about this concept of building your own airplane. I had never heard of this concept. He said, you can build these things called experimental aircraft at home, and FAA can certify it. So that's
how the phrase experimental aircraft, it sounds like a terrible idea.
It does. But, when I was a little kid, I got hit on my head. So I've always been crazy. So it wasn't too far-fetched for me. So I researched into it. And honestly, that night I didn't sleep because it brought back all my childhood memories where I wanted to design stuff and build stuff. And then I found out that you can actually build experimental aircrafts and FAA will certify it and you can fly it. So that's how the journey started in the aviation. I got my pilot's license. I started building my own plane, built it. And then given my background was obviously engineering, but then my first job was in the communications industry, in telecom industry. So I used to work with a company called Ericsson. So I was their principal architect, worked for them all around the globe, then co-founded a company in the telecom mobility space that I exited. And then when I exited that telecom space, based on my aviation and communication background, I got the opportunity to work with the US Department of Defense on drone and communications programs. So that was the touch from going from crewed aviation to the uncrewed aviation autonomy side. And worked there for many years, saw the transition happening to the commercial space because drones have been around in the defense arena for decades. They are relatively new in the commercial space, but in the defense arena, they've been around forever. So saw the transition happen, filed some patents and stuff, and actually built a prototype. I didn't build a prototype, to be full disclosure. Hired a couple of interns, paid them to build a prototype, and took it to an event in DC and got the coolest technology award. And I was like, there's something here. I was itching to start something again because I had run a previous telecom company and incorporated the company. And a couple of weeks later, was talking to the principal technologist at NASA who said, hey, we would like you to work with us and put a collaborative research agreement with us on this thing we call UTM, airspace integration. So that's how the journey started.
So you went to school for structural engineering and then for computer science. And out of that, you built your own airplane and got into communications. So I think the messaging for kids here is if you don't take the perfect degree, you're never going to make it in this life.
That's what I try to tell my kids too. One thing I always tell my kids is it's all, and even when we hire in the company, we look at the degrees, but we don't. That's not the only factor. It's the aptitude and the attitude you matters,
Yeah.
because the sheer definition of a skill is something that can be acquired. As long as you have the right mindset, I became the best student ever possible when I joined the telecom industry. For 6 months, I immersed myself. I learned everything possible. Similarly, when I got into the aviation, I had never built an airplane. I had built stuff around the house, but nothing like an airplane. And I scratch built an airplane, which means I fabricated each and every single part. So
Wow.
I had to I made a lot of mistakes. I had to learn and ask the right question, talk to the right people. So if there's will, there's a will, there's a way, is the point. And the only thing I tell people is, if there's hope for if there's hope for me, if I can do it, anyone can do it. Like I'm like a confused mass of problem. I've done like so many different things, but anyone can make it.
Okay, listen, I got to know, you're building your own airplane. You're building everything. You're building the fuselage. You're like knitting the wings or whatever the heck you do. How do you know this thing's going to fly? Like, how do you know you're not going to die taxiing down the runway?
So no. So there's some science to it. It's not. It's an art. It's not an art. It's a science. It's physics. Physics comes into play, right? So I actually purchased some blueprints and then I modified them. So there are standard ways you calculate thrust, lift, etc. And so what I did was I had the blueprints, and then I had a big trailer that, one of those 8-wheel trailer, big trailers. It pulled up in my driveway, in front of my driveway, with a pallet full of sheet metal. So I had these sheets, and my wife thought I was crazy. And then one by one, I started marking out the paths, cutting, and my garage and basement became an aircraft factory. And I started cutting and fabricating each part, messing up, making it again. Then there's an association called Experimental Aviation Association. They have volunteers around the country that you can ask for help. And so I found some great guys here who used to come over the weekend, look at what I was doing, tell me, yeah, that's not right. Maybe you want to change here and stuff. So it was an amazing journey. I learned a lot. I wouldn't trade it for anything else. As long as you're willing to make mistakes and learn from them and keep doing it, it's not as scary as it sounds. Now, you can't be reckless. So someone told me, because when I even worked on the power plant, which is the engine for the plane. I repurposed an old auto engine into an aircraft engine. So someone gave me a piece of advice. He said, if you, just like in your bloodstream, you don't want to put anything else in your bloodstream that's going to cause harm, think of an engine or an aircraft engine like you don't want to put anything in there that you wouldn't want to put in your bloodstream. If you treat it as that pristine of an environment, you'll always get a quality product out of it.
That's awesome. That's cool. I love the play aspect of it, like just having fun, building something you were interested in. Did you ever find that connected to other stuff that you were working on then? Like, oh, I learned this while I was working on that.
But that's always like the skills. Like I always was good at building stuff since I was a kid. Like I have caused so much destruction at my parents' place when I was growing up. I used to take things apart and not know how to put them back together. But you learn a lot. Like the biggest thing I learned is patience and persistence, because it took me 3.5 years to build a plane. So that's a long time. Some people take they get kits and stuff, they still take 8-10 years, and many don't even finish. But it was just a learning experience. Patience and attention to detail was very important, and the willingness to take critique and incorporate that in. And those are some of the things that you use in your daily life. Those are everyday that benefit you as an individual in your personal lives anyway.
Yeah. Oh, I love that. I feel the same way. I feel like there's so many things that you end up doing just for fun, and that passion that you have for it leads you down paths where you're learning things that end up applying in places you weren't expecting them.
Yeah, I'll tell you my favorite memory. One of my favorite memories when I was building the plane. I have 2 daughters. They were little. They were when I started building, they were probably 4 and 7. So they used to
good. So your wife was like, instead of in here helping me with the 4 and 7-year-old, you're building a fuselage.
So the kids used to come and sit in the workshop with me, and they would have these safety goggles and air muffs. And I have pictures. I love those. And they used to tell me, "No, you missed that hole. You need to deburr that," and stuff like that. So even when I finally closed up the fuselage of the plane, I actually had them go into the fuselage with Sharpies and draw their own creative stuff. So even today in the plane's fuselage, there's artwork from my kids.
You built the physical airplane, but instead of the hardware for drones, it's on the software side.
Yes, yeah. We focused on the software and the technology side. How do you integrate these at scale? Because building a drone is not as complicated as building an aircraft. It's a lot simpler. You can build, there are websites out there that show you how to build a drone. That's why, and they're depending on the sophistication, they can be very, very low. And you can buy $500-$600 drone versus $100,000, $200,000 aircraft, right? So it, I'm not trying to say it's not the right business. Hardware business has its own. It just didn't appeal to me because it seemed more like a commodity stuff versus we were trying to solve at scale. How do you make these skies safe? How do you integrate all these assets into the national airspace system? What are the challenges? That was a To me as an individual, that was a more compelling problem to address and solve. And if you go to my basement, you'll see a bunch of drones there too that I have built. But that's more for fun and recreational purposes, not from a business point of view.
So you went from the telecommunications business and then into software on the drone side, and kind of you ended up doing some work with the government, with NASA. How did that all form, and what was the situation there? What were you actually producing there?
So let's say you go to the Boston airport and you want to take a flight to DC today. When you get into the plane at the airport, you don't have to worry about that plane bumping into other aircraft or going into buildings, because the guys in the tower, air traffic control, are guiding them, giving them clearances, giving them vectors and stuff like that. Give or take, today there are 10,000 crewed aircraft, piloted aircraft in the sky at any given time. But when you move to the uncrewed world, eventually there will be hundreds of thousands, if not millions, in the sky at the same time. So the same human in the loop paradigm doesn't scale. So it needs to be a more automated digital system with a lot of advanced capability, machine learning, AI based capability that automates a lot of these capabilities. There'll be a human on the loop, not in the loop anymore, for this scale to really happen. And how do you do this in a digital fashion, move away from those analog voice calls? Because we're not just talking about these small drones that are flying, doing package deliveries or inspections. Eventually, we are talking about uncrewed flying cars, eVTOLs as their car, advanced air mobility or urban air mobility. They are going to coexist in the same ecosystem where these small drones are, where the crewed pilots are. And all this needs to be an integrated airspace, not a segregated airspace. So that's the problem we decided to solve from a digital point of view, build the digital infrastructure. Because what happens, we started this conversation by talking about the plane I built because it's a fascinating thing. People always get attracted by the shiny object, but what is the digital thing, that the glue that holds it all together and makes it all work? Because I can build the coolest, shiniest aircraft out there. If I didn't have air traffic control, it wouldn't go anywhere. So that's in essence the same analogy. If you look at from as drones start to scale, and advanced air mobility, urban air mobility, we kind of bring that glue in to tie everything together.
So today, are we automating any parts of like that air traffic control? Like everything I know of it is, humans doing that. Is that true, or is any of that automated today with airplanes?
There's if you're flying from Boston to DC, 99, I shouldn't specify person because someone might say you said the person. It's a very high likelihood that an autopilot is flying your flight. The pilot is sitting there in the cockpit, but it's an autopilot that's flying the flight. When you fly transatlantic, these are all autopilots. It's not a stick and rudder flying anymore. So there's a level of autonomy that is already on board. So there's what we're talking about is the onboard autonomy, but what we build is the off-board stuff, the ecosystem, the digital air traffic management system, which manages multiple of these aircraft flying in the same airspace. So if Amazon is doing a package delivery and Google Wing is doing a package delivery in the same area, how do they deconflict? Because there's no one on board the drone flying them. They are being remotely piloted. And in this case, they're not even piloted. They basically, there's a pilot on the loop, but there are automated missions it's flying. So how do
Right.
you deconflict those strategically and tactically? So that's one of the simple examples to consider.
Yeah. What about on the commercial, the commercial side of that for the traffic control? Is that all human, or is there any traffic control today of piloted aircraft that's automated? Is any of that automated yet?
No, there's always air traffic control. You have to use voice calls and file
Yep.
flight plans. You get advisories and stuff that are digital in nature.
Yep.
But from a control point of view and communicating with towers and other aircraft, it's all voice right now.
Yeah. So why isn't it automated? Any thoughts on that?
Because the scale is manageable right now. But the main thing that changes is scale. How many aircraft if you have one air traffic controller sitting in the tower and there are 5 aircraft coming in, great. Now change that number to 200. Can one aircraft controller talk to 200 aircraft in a span of 3 or 4 minutes? It's not practically possible.
Right.
Now you can keep adding people, but at a point that scale fails. You have to move into a more automated digital system.
Yeah. And what happens as we add more? I'm starting to dip into the future stuff a little bit here, but what happens as we add more drones into this system? And there's more, like you mentioned, there's more systems that maybe aren't piloted at all, let alone no pilot on the aircraft being a drone. Do those systems play together? Should they play together? Should they be separate? Right? Like, they're in the same airspace.
That's a great question. At the end of the day, this is an integrated airspace. It's the same sky. You can't divide. You can virtually divide. So currently, like for example, I can say initially in the initial phases, drones will only fly up to 400, 500 feet. The crewed aircraft will be above that. Works great because technically aircraft are not supposed to fly. Crewed aircraft are not supposed to come below 500 feet unless there's a specific need, like when they're landing or taking off. But crop dusters always fly below 400, below 500 feet, right? So they're the exception. And helicopters, medevac helicopters. So, but there is some level of segregation already out there. But when you are moving into like flying cars, eVTOL space, these aircraft are going to take off from the ground where the small drones are. They're going to move up into a higher altitudes where the crewed aircraft are flying or the piloted aircraft. So they coexist. So they're crossing the boundaries, right? And now all of a sudden, I can't say I'm going to create a segregated corridor where just these aircraft operate and a segregated corridor where crewed aircraft operate and a segregated airspace where only drones operate. Eventually, they are going to have to operate in the same airspace. Today, for example, there are drones that operate in our national airspace for security reasons and defense purposes. They operate in the national airspaces. You don't see them. They're flying up high up, but they're already integrated. But they're integrated with the traditional crew traffic management system in terms of walking, broadcasting. But as we start to scale, you have to create a system that allows for strategic and tactical separation and deconfliction of these aircraft so they can safely fly. So think Star Wars. Like people laugh when I say Star Wars. You see those aircraft I shouldn't say aircraft, those vehicles just, they hover, then they go up, they zigzag and everywhere. Eventually, I'm not saying today, but future, you have to account for scenarios such as that, where there are different kinds, different classes of aircraft operating in the same area. And you have to have some level of onboard autonomy, intelligence, as well as offboard traffic management, which allows for these systems to safely separate.
Right. Yeah. No, that makes a lot of sense. Like drones are already doing it. Do you think we'll get more sort of VTOL commercial aircraft, or that we'll get, how viable are personal like transport drones, like,
Personal
these taxis
flying cars,
and
personal flying cars.
Yeah.
So
Or personal or not, what are
Yeah.
you seeing?
So we are seeing, like I always say, it comes in innovation, experimentation, and operationalization. So you always start from innovation, you move to experimentation and operationalization. In the small drone space, small UAS space, we started back in 2014, 2015 in the small US space. And now we are at a point where it's becoming operationalization. In the flying car eVTOL space, we are still in the innovation experimentation phase. There's no type certified aircraft eVTOL currently. They are in the type certification phase with FAA, but there isn't one. And it takes years and years to certify an aircraft like a Boeing or an Airbus so you can put passengers on there and a lot of attributes. So the eVTOLs are currently undergoing certification. They will eventually get certified. But in terms of now, you have to look at the economies of scale, the business case, right? An aircraft like a Boeing or an Airbus will carry anywhere from 50, 70 passengers to a few hundred passengers, right? And you have one pilot flying it or a couple of pilots flying it. So there's enough revenue coming in that will justify a business case. When you move into the eVTOL space, most of the aircraft that are out there currently being built or promoted, they support at the most 4 or 5 passengers. And they're saying initially it was going to be optionally piloted. So if I put a pilot in there, I lost one seat. So I have limited passenger capability, limited payload capability. So even though they're electrical, they have other limitations in terms of how much battery life do I have? How far can I fly? So you can fly maybe 20, 30-minute routes. That still helps in urban congested areas. So there's a business case, there's a need, but it's not at a scale where I'll pull into my driveway, jump into my flying car and go fly to California tomorrow, right? The technologies haven't kind of gotten to that level yet. But initially I see when we talk about these advanced air mobility or urban air mobility, I see moving cargo and for logistical purposes, I see that use case coming up first, and then we'll start transitioning to passengers. And this will happen in our lifetimes. Like I said, this will definitely happen in our lifetimes, but it will probably not happen as fast as media thinks it will happen. But over the next decade, we will definitely see some level of scale happening. You'll see initial pilots and trials are going to start happening some have already happened, some are happening over the next 2-4 years, but at scale is still ways out.
That makes sense. So can you walk us through, give us a little bit of detail on your company and what do you guys do today? What problems are you guys focused on today, or what kind of stuff have you just recently solved that you can share a little bit and give a little bit of context for?
So at a high level, we as a company focus on what we call as airspace and mission management. So airspace is the aspect we were talking about. How do we manage and deconflict the airspace? In addition to that, we also help enterprises manage their fleet operations and flight operations at scale. Like, for example, New York Power Authority is a customer. They manage all their drones from a centralized operations center using our technologies. Similarly, National Health System in Scotland, we are working with them to help build a medical delivery network across Scotland as part of a project called KLS. So there are different use cases like that. And at the end of the day, you have to look at the end use case. What is the end use case? Is it a delivery mission? Is it a linear infrastructure inspection? Is it a surveillance? So there are some value-added services. So we have some basic services, underlying services, which is traffic management. But in addition to that, we have value-added services. Like, for example, if someone wants, you want to plan a drone flight from point A to point B, we have something called a rules engine or where you tell it, hey, give me the most optimum route from point A to point B. And our system will use this intelligence, machine learning, AI, and all different kind of data sets, terrain, obstacle, weather, C2 command and controls link, so which is how you control the drone, communication link, coverage map. So I can plan a route where you're going to maintain the link with the aircraft so you don't lose the link. And it'll give you a route where you have minimal weather impacts and you can reach the destination in the most optimum fashion. And if your drone has endurance to only fly for 20 minutes, I'm not going to give you a 30-minute route. So there's a lot of intelligence. These are some of these value-added features on top of the basic capability we offer. We have defense users that use our defense capability, where we are talking about right now, you and me are chatting about the good users, the good actors that are flying the drones, but there are malicious users that use drone as well. And with the wars going on, you're seeing how they're getting used as well. So at the end of the day, you need to get a common operational picture, which shows you cooperative and non-cooperative assets together. So we have some capability called Single Integrated Operational Picture, which does that, which ties it together, counter UAS and UTM together, and marries it together and provides a comprehensive capability for defense and security agencies. This capability is currently used by some of our defense customers already. So those are some of the things we are working on, and then we are working on some newer, more forward-looking, future-thinking solutions around advanced air mobility. Like last year, we launched something called a vertiport management systems, which is the airports of the future, which might be in your driveway, on a ramp, or existing heliports might get converted to it, or on top of a building, rooftops. So the digital infrastructure that makes that vertiport work and ties to the airspace integration. So how do you ingress, egress? How do you integrate? Do I have a charging pad available? Do I have a landing pad available? Things like demand capacity balancing. So if I have 2 landing spots on the pad and I have 3 aircraft coming in, how do I sequence in it? Just like if you ever seen the aircraft coming into the Boston airport, you'll see them sequencing one behind each other, like they sequence them, space them out. Now you have to handle similar kind of stuff for vertiports. So how do you do those kind of things? So just giving you some basic examples. We do a lot more than that. I'm trying to kind of put it in layman's terms, so gives you some examples of some of the things we do.
Yeah, no, those are great. Those are great. I remember coming into O'Hare out over Lake Michigan, and as the plane turns to come, I don't know if it was getting into line or what, we were turning to land or whatever, you can see at night the row of lights that is just airplane behind airplane behind airplane behind airplane. It's pretty neat to see that it's how they're stacked. So that's really interesting. And you had mentioned NASA. Are you guys doing anything in space and space flight and that kind of stuff, or on your way to it?
Yeah, so this whole concept of what's called UAS traffic management was actually born out of NASA. It was a research paper that was published in 2014 by a gentleman named PK. And he's the principal technologist I told you we talked to, and who called me in 2015 and said, you should work with us. So that's how the journey started. So NASA doesn't just work on space. When people talk about NASA, people just by default think of space. NASA does a lot more things. This is the NASA aeronautics. So they do other stuff too. So that aspect, the aspect of NASA we've been working on since 2015, is focused on uncrewed aviation and aeronautics. Now, to answer your question, are we doing something in space and stuff like that? Not as a business currently, but me as a personal, I have a very deep interest in that space. So, and some of the things that we are doing currently for UAS, there are similar touch points. There are concepts such as space traffic management. As more and more assets get into space, how you have deconfliction issues in space too. That's more futuristic. It's not going to happen right now. We already have space debris challenges, but there are concepts like upper E, higher altitude traffic management, eventually space traffic management. So we see that as something that's down the line, future kind of thing. But as a company, we are not working on. But me as an individual, I am very interested in that space, and I look at some different. I'm engaged in some other initiatives around that space just for my interest.
That's great. So, for context for our audience here, is there's a few things about NASA. One is, so talking about drones and if we talk about the moon, drones don't work because there's no atmosphere. So we're talking about ground-based vehicles, but you can still have.
That's not true. So if you look at Mars rover, have you seen the Mars copter, the helicopter that they?
Yes, so Mars has an atmosphere. The moon doesn't have an atmosphere.
Yes. So there are some places where you would be able to do
yes,
that kind of stuff.
Absolutely. And there are some propellant-based systems like mini rockets that they've demonstrated for even the moon without an atmosphere, so you can keep yourself off the ground and all kinds of stuff. But on the moon, you've got to have ground-based vehicles unless you're doing some sort of crazy propellant thing that lasts 20 minutes until you're out of propellant. But the NASA has not yet deployed a swarm on a planetoid. So in a sense, they do with satellites, right? But they haven't done swarms. And so we were working with NASA to do swarm. And so the first one is actually scheduled for later this year, the Cadre program, to head out to the moon to do ground penetrating radar. Now, that being said, NASA, we're having these discussions with NASA about like how we're going to build habitats and how we're going to deal with space traffic. And we're like, wait, we haven't even gotten 3 ground-based vehicles together in space yet. They're like, yeah, but if we aren't working on it now, when we get there and we have the problem, we won't be ready for it.
Right. Yeah, that's
And
always like you can't wait till you get there to build this. You have to have the solution ready when the opera time comes.
yeah. And so it's very common for NASA to be building something for 10 years out or 20 years out. And so that's what's pretty interesting is certainly we're going to get to the point where not just the sort of traffic control, but the coordination of tasks and coordination of like just the cooperation of autonomous agents and all that kind of thing. So whether satellites or things on planetoids like the moon or Mars or what have you. So that's pretty interesting. And like the kind of stuff that you guys are building seems like it would be a perfect fit for those things as they roll out in the future.
Yeah, so you're absolutely right. So the technology we built, when we built it, we started with the air segment, autonomous air segment, because that's the most complex one to solve. It's in 4 dimensions, space and time. It's once you have solved the 4D problem, it's a lot simpler to solve the 2D problem, ground or maritime, because our system, even though it's built for air, it's been proven and demonstrated to handle air, ground, and sea assets in the same common operating picture. The same technology actually does that.
Nice.
So, and as you move forward, you'll have a lot of multimodal deployments, which are combining these different modalities together. So you have technical touch points there as well.
Yeah. And the complexities continue to increase, right? Because there's a funny use case of like, what about a duck boat? Right. So
it's not just a duck boat, an autonomous duck boat.
There you go. Right. An autonomous duck boat that launches drones. Right.
Yeah.
So that's one of the things I think is so interesting about as we're pushing forward in all these things is, I mean, we're being a little bit silly with our autonomous duck boat that launches drones. But if you think about it, that's not that far fetched. And yet today, all airports are stationary. But the kinds of things that we're building in the future, the airport in that sense, or where you deploy your aircraft from, may be a mobile
it's already
unit.
happening. So there is they have drone in a box solution where you can launch a drone from the back of a moving truck. In fact, I forget, I'm drawing a blank right now, but if you Google, you'll find out. Just a couple of months back, there was an article. So for one of the defense projects, they actually launched smaller drones from a bigger drone in the upper atmosphere to launch. So you're not launching from the ground. One bigger aircraft is launching smaller aircraft in the sky, and for the mission. And then I forget if it came back and landed there as well, but those concepts are already being worked on.
Yeah. That's awesome. The sorts of things that you're operating in, I think, are so interesting because they're outside of the purview of the thing I think normal people wandering around are thinking about, even when you're thinking about the future. Like you think about the Jetsons and flying airplanes, or flying personal airplane, or these kinds of things. But the systems to coordinate all those things are so important in that process and enable capabilities that otherwise might not be there. I think that's a really interesting aspect of it all.
Yeah, absolutely. And so we can't do the ostrich thing and put our head in the sand and think it'll never happen. It's going to happen. So we have to be prepared for it. And there's obviously a social acceptance side of it, but it's going to happen no matter. There's certain things you can't fight. Autonomy is here to stay, and it's going to change the way we live lives, just like AI is transforming the way we live lives too. So Uh,
Yeah.
I just need to learn to deal with it and move on.
Yeah. Yeah. And, I always think about the pivots that we're going to see in the future. So if you think about the iPhone came out in 2007, and it was a pivot no one was looking at, maybe except Apple at the time. And all of a sudden you had this device in your hands, you had all these access to all these things. But we thought before that music, we just kept thinking like, well, records will get smaller, and they did. And then we had CDs, and then we'll have CDs that are super small, or we'll have CDs. And then there was some other thing that happened, and the technology sort of transformed. And now we carry the thing around with us all the time that has music, and we don't care how small it is because it does other stuff. So I wonder how that works in aviation. Like, I keep thinking, okay, we may eventually solve the speed of sound problem, and we can go faster than the speed of sound. And I can get from here to LA in 2 hours or in an hour instead of 6. But how do you think about that? Do you think it is that we just keep finding ways to do it faster, or does it become more convenient or autonomous in some way, or is there some other twist to that puts us in a future that's interesting in a different way?
Honestly, the way I look at it, I think the thing that's going to probably surprise us the most, we probably haven't even experienced yet. It's just like when you use the iPhone example. When the iPhone was launched, it no one thought of the app store revolution, all these apps that would come. So iPhone just became a means to an end. Eventually, the apps that change the productivity and change the way we live our lives. So I think similarly, autonomy is just a trigger. What use cases and application it enables, I don't think we have even scratched the surface. We are just barely there. So if I had a crystal ball, I would start a ton of businesses if I knew what was going to be there. But you're right. So I, and I'm not quite answering your question, but I'm just kind of trying to share the way I think about it. It is like we don't know what we don't know. We don't know what's going to be the most transformative thing. It might be something that might come out tomorrow, and then things change, but maybe a couple of years down the line.
Yeah. Yeah. And I want to pull back something that you said before we actually started the podcast. You said that I think we were talking about commercial passenger drone technology, but you said it's not a software problem. It's not an IT problem.
Yeah.
What do you mean by that? What are the problems we actually have to solve there?
That's a great thing, and it's a pet peeve of mine because I'm in the software, but the problem we are solving, especially us, what we are doing, it's an aviation problem. So what happens is a lot of people, I won't single out anyone, come and say, "Oh, we are a great software company. We'll write amazing software. We know how to solve. This is a software problem. We just move ones and zeros and we solve the problem." That's so far from the truth. That's the challenge where people think they know the problem and try to build a solution using the limited knowledge they have of their field. This is an aviation problem. What we are trying to, a lot of things we deal with is not how you solve it by writing software. It's what are the procedures, what are the concepts, how do you deconflict, how do you maintain well clear separations. So you have to understand the basic fundamental aviation air traffic management paradigm. So it's an aviation problem we are solving, and software is just a means to an end. So that's what I mean. So you have to understand, uh, and and if you were to go in, I was joking with some people the other day. I said, someone said, "Why don't you hire more salespeople?" I'm like, if I hire a sales guy, like a car salesman or any salesman for that matter, and have them go sell our technology, they go in front of a regulator and start selling, and the regulator asks them a basic fundamental question about what's well clear. How do you define well clear definition? And they'll be lost, right? So you have to understand what problem are you trying to solve from the core point of view before you go pitch a solution. So that's the challenge we are seeing in a lot of, at least in our industry. A lot of people think it's just a pure an IT problem. It's not. IT is a means that's helping you solve it, but you have to understand what the problem is first.
Yeah. And you know what I love about that is we so often, I think, are so hyper focused on the field that we're in. Like as society has grown, as technology's grown, we become more and more specialized, but to the point where we don't understand how the world around us works. And it's what I love. I don't know that you would have known that this is an aviation problem like you do today if you hadn't built your own airplane and be interested in that process. And we're just solely focused on software, right? That kind of breadth that you have feels like it brought something unique there.
You're absolutely right. There's no substitute to real world experience. So when I was working on drone and communications programs with the Department of Defense, and drones weren't really a thing in the commercial space. The kind of challenges I heard about that existed at that time, I was like, fast forward 5, 10 years, when these things come into the commercial space, we are going to have similar challenges there. And we're going to have challenges at scale, because scale will be a lot bigger than a Department of Defense deployment.
What do you think that scale looks like?
Scale in terms of numbers, or it's like if I have to give you a multiple, it's probably like 100x, 200x of what it would be in the defense, or probably even higher.
What's that look like in the sky, or what's that look like in our lives? What do you think?
So some people say the sky will be black with drones in the sky. I don't think we'll get to that point, but you're going to have, like, if I was to say the next 10 years, you'll probably have simultaneously hundreds of thousands of aircraft in the sky.
What do we have today? Do you know, as like a comparison?
I don't have an exact figure yet, because each country, each regulatory framework is different, and the regulations are preventing people from doing this at scale. There's a lot of recreational users, but if you look at the registration databases, there are hundreds of thousands of officially registered drones in the FAA database. The last I checked, it was, I think, like 900,000. I think it's probably higher now. I don't know what the number is currently. Similarly in other countries. So, but not all of them are flying at the same time. So
this one's on the shelf right now. I don't know if it's in the view, but it's back there. But do you know what it looks like for airplanes? Like, do we have hundreds of thousands of airplanes in the sky right now over the US,
no,
for example?
that's what I gave you that figure. So like in US, it's the figure says, and given in the airspace system, at any given time, they say there are 10,000 aircraft in the sky, crewed aircraft in the sky.
Yeah. That's really interesting. And you know, just to visualize it, if you go outside, you can probably find one or two at any given point.
Drones?
It's not,
or aircraft.
Aircraft.
Yeah. If you stand out long enough and look around, you'll probably pick up a couple.
Yeah.
And so the thing is, there are a lot more aircraft you just don't see because they're flying high. But if I was to put an ADS-B receiver pretty much anywhere, I'll guarantee you within a 20 mile radius, you'll pick up quite a few.
Yeah, that's interesting. Yeah. So like you said, like people say like, oh, the sky is going to be black with, if you think about what it looks like today and then say, okay, maybe it's 10x that, maybe it's 100x that, but how many are too small to even see that far away and that kind of thing.
Yeah, and see, this goes into the other topic, which is a controversial topic people talk about, is privacy concerns and stuff. I don't want drones flying over my house and stuff like that. I don't think people realize there are aircraft flying over your house. You just don't see them. There's satellites taking pictures every day over your house. You just don't see them. But it's already happening. So, yeah.
That's right. We care about the privacy when we see the privacy concern. It doesn't mean it wasn't already there. Yeah, that's exactly right. So as all this moves forward and what's, from what you see in the industry, this kind of thing, if you had a magic wand, what gets us to the future? What thing would you tap with the magic wand to just instantly fix to accelerate us into the future? What would that look like?
I think the challenge for this industry, and specifically any leading in industry, especially safety critical industry, there are some non-safety critical industry that's different. Aviation has higher standards of safety, and rightfully so, is regulatory framework. So what has held this industry back all these years is the regulatory framework. Because unless you have a regulatory framework or a target to shoot at, you can keep building stuff, but you don't know if that's what's going to be acceptable or not. That was the challenge for this industry, big time. And then finally in Europe, the use-based regulations became a law in 2023. So now there's actually a target to shoot for, and people have to start complying with it. Similarly, in US, we are a little behind on the regulatory framework, but now with there's work going on what's called Part 108, and with the initiative that we are actually leading an initiative in Texas with FA and other industry partners, where it's called the U.S. Texas Shared Key Site, or they call it Texas Key Site or Shared Airspace Project, where multiple operators are operating drones, commercial, not trials, not demo, for operational commercial use in the North Texas area, and they all need to be deconflicted. So we are not only non-vertically integrated technology provider. They're providing services to a delivery provider and public safety departments as well. So that is going to help feed into Part 108. And to answer your question, what would I do with my magic wand? I would fast track the Part 108. So it actually allows us to start scaling beyond visual line of sight operations, because that's where the true business opportunity is. There are opportunities in the visual line of sight drone operation, just doing a rooftop inspection, but this larger business opportunities are when I can fly these drones beyond visual line of sight for different use cases: delivery, inspection, surveillance,
Yeah.
etc., etc.
Yeah. Oh, that's interesting. And it's interesting how often I'm talking to people with that question, and it's not a physics thing, or it's not a people building software. It's a government regulation or a government decisions, those kinds of things. So, but it's also interesting that in this case, it's not the regulations are in our way. It's that we don't have specific regulations. Is that
Well,
right?
we don't have regulations that enable us. So the regulations that are there were put in place decades ago, designed for traditional forms of aviation, not these new forms. So they are, in a sense, blocking it, because they are not, and rightfully so, because they were designed for a different purpose. You have
Right.
to design
Right.
stuff for, it's time for change. We have to relook at how we do things, and the future is different.
Yeah. Yeah. That's great. As you look to the future, what's the thing for you you're most excited about? Whether it's in this or anything, what's the thing as you look towards the future that's interesting?
What I would be most excited about, and I mentioned this like a couple of years back at another talk. I said I would be excited, like when I'm old, and my kids come to fly in their own flying car and land in the backyard and come in and see me. I see them flying in a flying car, and it's a reality. That would make me happy. Like I talk about, like I think we chatted about it. Like, I don't know when it was last time we spoke. It was like, what drives and motivates me is, like, it's not the financial aspects. Yeah, there's always financial aspects and stuff. It's like, because I could be doing 10 other things, different things, and making a shit ton more money, a lot less stress, a lot less worries. But that sense of accomplishment is missing. Like, I want to be on my deathbed and look back and, like, hey, did I do something important with my, like, what did I do? And at least I'll be proud to say, hey, we played a small part, not a big part, a small part in this whole autonomy airspace management challenge, when this new entrants were coming into the space. So we had a small part to play in it, and that makes me happy. Like, that's a sense of accomplishment. I wouldn't trade that for anything.
Yeah. Oh, that's fascinating. And that's awesome. I think that's what we're kind of here to talk about too, right? Is how we push things forward in a way that you can be involved in, I can be involved in, or listeners can be involved in. Like, what's the thing you can do here that pushes the needle, that's that makes it interesting and worthwhile. So I absolutely love that. That's fantastic. So I think for listeners, how can they find you? How can they find your company if they want to work with you or follow you on socials, or what's the place to look for you guys, find you?
Sure. So you can find me on LinkedIn Amit Ganjoo, AMITGNJO, ANRA Technologies. You Google, I'll probably be the first thing that'll come up. We have a LinkedIn page. Our website is www.flyanra, FLYANRA.com, flyanra.com. And there's a company LinkedIn page. You can find us there, and you can reach out to me directly on LinkedIn or on our website.
Awesome. Hey, thanks so much for joining us. This was a super interesting conversation, and I really enjoyed all the different tributaries that took us down in various parts of technology. It was really interesting.
Well, thank you, Brian. It's a pleasure. I know we kind of, like you said, we meandered around a bunch of different things, but I enjoyed the conversation, and thank you for giving me the opportunity to chat today.
Yeah, awesome. Love it. Thanks so much.
Thank you.
Okay, I really loved Amit's take on where things are going in the future. He had a unique way of getting into things, talking about things like how we're going to control the airspace. So I'm here with Harriet Koromoa. We're going to talk through a little bit of this. Harriet, first thing I want to know is, what do you want to have drones deliver to you?
Forever 21. The store. I don't think that's possible, though.
Like, you want to have them deliver that being 21 years old. Forget bringing goods and services. Let them just bring my age back.
I'm still young, Brian. Thank you. Just so you know.
Okay.
But yeah, I think like you build your own drone, so I think the concept of drones dropping off an Amazon package is a pretty cool idea. It has a little flair, and a little entertainment. So I don't know what I would want a drone to drop by, but I would like to see that maybe in the future, maybe tomorrow, in case somebody's working on it.
Yeah, we're going to get to the point at which you're just asking for things. Like, I heard one comedian say, "I want candy now, on my tongue now," and just drones are dispatched to bring your Werthers or whatever to immediately deposit it on your tongue.
That's kind of scary. Okay.
Right? All right. So there was a cool article that I thought I'd read a clip to here real quick.
Okay.
It's a really interesting stat from this write-up from Rich Shea at Johns Hopkins Magazine. And he says, drone technology is advancing so rapidly that the Federal Aviation Administration forecasts that by 2027, that's like soon, close to 1 million commercial drones in total will be in operation, doing everything from delivering our pizzas and packages to assisting in emergency response. Now, he left out the Forever 21 part. I think that was remiss from his part, but I'm sure he meant to include it.
I'll take what I can get, right? I think I'm okay with pizza delivery, so for now.
It'd be good if they could get it there still warm, Maybe we can use the drone battery to keep the pizza warm.
Oh. Okay. No, I don't like that idea at all.
I don't want warm pizza?
I just don't think it matters. Like, as long as the
warm
drone
pizza, cold pizza, who cares?
Right. As long as it's like entertaining, like it should dance a little bit. Cause I'm guessing we're gonna give it a tip. And like, I don't want a drone to drop off my pizza without shucking and jiving a little bit,
You don't care if the pizza's warm as long as your drone twerks?
Mm-hmm. As long as it's entertaining.
All right.
Don't judge me. Okay.
All right. We're here with a Harriet take today on drone technology of the future.
It's an interesting problem. Amit and others are trying to solve in the drone industry. When I think about it, simulating autonomous traffic air control, it's not an easy job to do. I wonder if you know any factors when trying to do that, Brian.
Yeah, I mean, I think there are a few different things. Like, One is certainly simulating those things, but you have to also simulate the human pilots in the mix, because I don't think we're really, really close to commercial airliners being autonomously driven. We're maybe not that far away from them being able to be autonomously driven, but grandma needs to get on the airplane and be okay that there's not a human pilot up there, which we're probably pretty far away from yet, which means that we're going to have both autonomous drones in the sky and we're going to have humans in the sky. And so I think that mix is going to be interesting. How do we simulate things like, I just saw or listened to the recording of a single air traffic controller in a tower at an airport, and an airplane crashes in the process of trying to get back to that airport. And so now he's not coordinating traffic. Now he's like, everyone needs to hold for 30 minutes while I call local law enforcement, while I try to get ambulance out to the plane that crashed. That's super different than just, hey, I need to coordinate a million drones that are in the air. Like, that's a algorithmic problem that we can solve, and we can solve that with math. But what happens when a human pilot crashes, or what happens when a drone crashes or crashes into someone's house, or right, those kinds of things, like, who do we have to notify? So there's that aspect of it, as well as the aspect of the simulation of the airspace. So I think those are both problems that we're going to have to solve as we move into the future.
Yeah, I mean, he brings up the topic. This is one thing that was really interesting to me. He was like, now currently the pilot is like autopilot. Most planes are on autopilot. The which I was like, oh, okay, well that's scary, but okay. But I thought that was such an interesting thing because we don't really know the behind the scenes what's going on, and so convincing people about, oh, it's already happening. How do you convince people that it's already happening, get comfortable with it, because they're not aware. I'm not aware that most planes can run on autopilot right now for hours, and the pilot just has to be there to control it just slightly. So I think that was one of the interesting things that I was thinking about when he mentioned that these things are already happening. How do you convince people to be okay with it, or how do you convince people that it's fine and it's safe? So
Yeah, I mean, I don't know that we do, right? There's so many things where you get early adopters, and those are people who are willing to work with things before other people are willing to, and then you get the masses who will accept it. And where do we get to that point? I don't know. But I think, to your point, right? Like, oh, I didn't realize, like, pilots aren't piloting maybe as much as they're captaining,
right.
if we could say it that way, right? Like, they're managing the aircraft. And people, like you said, people don't know that. If people knew that, then
It
they
would be a
might,
different conversation.
yeah.
Hmm.
And they might be freaked out about that or whatever. I mean, but you're also kind of happy that the pilot's still there, so you're probably okay with that. But realizing that, okay, now if you replace that and replace what's happening with the pilot there with the autonomous systems, then we might be closer to accepting that if we knew what the pilot was actually doing today. I think the other part of that is we tend to go, one step at a time. Maybe what we do is we don't need a co-pilot all the time. Maybe the autonomy is our co-pilot, and we end up with just the redundancy is in the autonomy, and we need just a pilot. And so maybe we can help, which, by the way, we're dealing with a labor issue. We don't have enough pilots. Okay, so that article goes on to say,
Hmm.
the new study goes a few steps further, using a 3D simulator with noisy sensors that anticipates the autonomous aspect of future drones and applies AI algorithms and AI assurance to various inevitable and unexpected occurrences, such as mountainous terrain and skyscrapers, last-minute changes to flight schedules, and the sudden appearance of a flock of birds or a rogue drone.
Wait, you said it uses AI sensors?
It's using AI algorithms and they mention AI algorithms, but it's using noisy sensors. So in other words, a normal sensor or a sensor that's giving us good data would give us what we would call clean data or clean data from that sensor. Noisy data is going to include things that are just random. So we call it noise when it's random, like an old static on a radio or a TV. Or it could be wrong data. We could have some aspect of wrong data. And so like we're trying to get something clean from, so let's say, what's our distance from the airport? And instead of going 100, 99, 98, 97, it goes 100, 53, 140, 99, 58, 98, 160. So we get the like 100, 99, 98. The signal is in there, but we've got this random stuff bouncing all around. So that's what we call a noisy sensor. And so if we get that data, we need to understand, like if you were a pilot getting that, right? What you might do is go, this sensor is no longer good. I'm going to my backup sensor. Or you might go, the needle's going like this, but it looks like the middle is here, right? Depending on the sensor. Like some sensors, that would be a totally invalid reading. Some sensors figuring out that it keeps going from here to here, so the real signal's probably here. Some sensors, that would be an okay thing to do. And so they're talking about using AI to determine some of those things, maybe clean up the noise from the sensor, maybe figure out what the real data is, or like a real pilot does, you might go, forget this sensor. This sensor's bad data. Let me move to my secondary sensor, or let me move to some other set of sensors which can imply the same data, right? These kinds of things. And so, for example, maybe I can see my nose sensor and my nose is staying up on the plane, but my altitude says it's dropping. Like, can I verify that my altitude's not dropping if in fact that sensor's bad, right? This kind of thing.
Okay.
And so actually one of the things we've done at Geisel is we built a framework we call Giraffe, which actually lets us inject noise into the sensors that we feed the drones or other devices for exactly this reason, so that if you're going to train your algorithm on what it should do in various situations, well, if the data is always good, then when you get bad data in a real life situation, we don't know what you're going to do. You might do the right thing, you might not, but the worst problem is we don't know what you're going to do. And so by being able to induce noise, we can induce bad data. We can induce spotty data. So in other words, that signal that you get that's 100, 99, 98, you get 100, you get 96, 95, 89, right? So you're missing some data. And so we can simulate that. All those kinds of things we can simulate with this. And so what we used to do was we would build the drone in something like MATLAB, where we could get all the math right. We'd build it, we'd test it, all this stuff. But we can't run MATLAB code on the drone directly. So now we go, okay, we know how it works. We throw that away. Now we start writing robot code for the drone or for the AMR or ground-based vehicle, whatever, what have you. Now we're writing robot code for that. So Giraffe, what this product does is it lets you write your robot code from the very beginning, run it in the simulators, run it with, so one of the issues that we have is your drone is very tiny, usually. There are very large drones and all kinds of things, but often your drones are very small and they have limited battery, which means you have limited compute. And so if you want to like calculate, is this the object I'm supposed to target? Is this a object I should avoid? Like all that requires compute power to like think, right? If anytime the drone has to think, that's requiring compute power. So what most of the time they do in a simulator is you have this huge computer that simulates many drones, And the code for the drones, the software that's running on the drones, anytime it has to think, it gets to use the giant computer brain. But then when you run it on the drone with the little bird brain, you find out, oh, I don't have enough processing power to actually make that calculation. Do I avoid this tree or whatever? So you run into the tree. So one of the cool things with Giraffe is you can actually simulate it, but you can actually use the physical, I'll call those microprocessors, the bird brain that's going to go into the drone. You can use the actual bird brain that is going to go in that drone so that your simulation is really the real code running on your robot. It runs on the actual drone. And if you don't have enough compute, you find that out in simulation, not once it's up in the air wrecking into things.
That's really cool. I mean, I heard a little bit about Giraffe, but I'm still learning about that because I'm more into the synthetic data right now. So I'm still wrapping my head around that. But it's really cool that it's like that advanced and you can tie it into that. Was that the one that we used on in NASA or?
Yeah,
Okay.
exactly. So one of the projects where we were helping NASA, and actually this ties into what Amit was talking about in a really cool way, I think, is when we think about progress, like the first thing we're trying to do is get a robot to work. NASA's projecting out decades in the future. So what we're working on with NASA is getting swarms of robots to work. So this could be 3 robots. In fact, we wrote some code that's going to be deployed on the next moon mission for NASA that's going to have 3 ground-based vehicles. I think I mentioned this in the interview with Amit that's doing ground-penetrating radar. So we'll use 3 for that first one. And so the swarms is like the next thing that we're working on. How do we get swarms of 3, then scale that up? How do we do swarms of 50,000 where some of the agents are just providing where you are, like GPS does today.
Mhm.
But on the moon, we don't have GPS because G is a globe and that's Earth. So the other ones don't have GPS, Mars or the moon or whatever.
Maybe he has an MPS, but that's
Right.
funny.
Right.
Okay, you got my joke. Okay.
That's exactly right. So, so we need a way to be able to do these different things. Maybe we have some that search for water, some that dig, some that extract materials. So we have all these different drones and robots and machinery that all works together. We need to have all those things work together. Then the stuff that Amit was talking about takes it to the next level, where if we have 1 million drones in the sky, maybe we have a swarm of 10,000, somebody else has a swarm of 10,000. We don't communicate with them necessarily. Different companies, different protocols, whatever. They still have to deal with that from the air traffic control side, which is the cool thing that I like about the future that he's looking at, because he's looking at how do we control the airspace. And so,
I was just thinking about that. Like, I was just thinking about when you were talking about the swarm of robots. I was like,
yeah,
you need somebody to control the traffic of that. And I was like, oh, okay. I
Yeah.
see. I see what Amit was talking about. I see
yeah,
what he was getting at. They're really ahead of the game, and it's just so cool to really listen to this interview and to be part of it, to hear what they're doing. So
yeah, yeah. I really liked the aspect of like when we control all the drones, that's one situation we can take care of all of it. But if you think about air traffic control today, it's just we don't control the airplanes. Air traffic control coordinates all of them, right? It's not controlling, it's coordinating. And so now we're talking about how do we coordinate maybe millions of drones, and not only millions of drones, but this is where it gets really interesting, and where the kinds of things Amit's team are trying to solve is when we talk about controlling the human pilots or coordinating the human pilots with the autonomous drones, that I think gets really into, and this is what I love about this show, is that future that we aren't necessarily thinking about, but somebody is thinking about that really specific aspect of the future, which is pretty cool.
I'm going to have a flying car in 2027. No, I really wonder if Emmett would. I don't know, since he knows you now, I wonder if he would give me my first flying car. No, that's greedy.
Yeah.
Harriet. Okay.
Yeah, that's okay. Thanks, everybody. We appreciate you checking out our podcast. Have a great afternoon.